Hello everyone, Assalamu alaikum. Welcome to MJ's Math Assist. This is Mohammad Jahangir Hussain. Today we are going to solve a mechanics paper from option number 23. So without further ado, let's get into the question paper directly. So this is a mechanics paper from Cambridge International AS and A level, option number 23, variant 42. So let's start with question 1. In question 1, you see a block of mass 15 kg slides down a line of greatest slope and an inclined plane. The top of the plane is at a vertical height of 1.6 feet above the level of the bottom of the plane, and the speed of the block at the top of the plane is 2 meters per second. Speed of the block at the bottom is 4 meters per second. Find the work against resistance to the motion of the block. See, it slides down. So initially it is at the top of the block, top of the plane. So let's draw it on a rough diagram. This is the inclined plane. Initially, the object is at the top of the block, top of the plane, which is moving with speed 2 meters per second downward. And at the bottom of the plane, its speed is 4 meters per second. And the distance it moves along the plane is not given, rather the height of the top of the plane above the bottom is given. So what are the changes occurring here? You see it got an increase in kinetic energy and gravitational potential energy loss, and there is work against resistance. No external force. So if you figure these three things first, GP loss will be mg into 8. M is 15, d is 10, 8. The height it loses is 1.6. So that's the GP loss. And K gain is half into M into V square minus U square, half into 15, V square, that's 4, U, 2. So substitute this. Then we need to find the work against resistance. So if we apply the work and differential here, we'll have GP loss equal to gain plus work against resistance loss equal to gain plus work against resistance. So loss, we have GP loss here, 150 into 1.6, K gain, 15 by 2, 4 square minus 2 square plus work against resistance. So calculate this one and you will have work against resistance equal to 150 joules. So work against resistance is equal to 150 joules. That's number one. Now let's get to question number 2. In question 2, you see this diagram. The diagram shows a smooth ring. So the ring is smooth of mass m kg threaded on a light inextensible string. The horizontal force of magnitude 2 Newton acts on the ring. And the ends of the strings are attached to fixed points A and B on a vertical wall. The part AR of the string makes an angle 30 degrees with the vertical, and part BR makes an angle of 40 degrees with the vertical. The string is taut and the ring is in equilibrium. Now, what is the significance of a smooth ring here? Don't tell me that it represents there is no friction. Okay, fine. There is no friction, but how we use it here? Whenever a smooth ring or bead is threaded on a light inextensible string, the tension on both segments of the string will be same. Tension on both segments of the string will be then if it was a rough ring, then tension would be different. Okay, so that's the significance of smooth ring. So apart from the tension in the strings and the applied horizontal force, there is another force, that's the weight of the ring, which will act vertically downward as m. mg. G stands for 10 m Newton. That's the weight of the ring. Now we have two unknowns here, M and T. You have to calculate the tension in the spring and the value of M. For that, if you consider, since it is an equilibrium, you have to consider two axes here. Let the horizontal, the direction of T Newton be the x-axis, and perpendicular vertical be the y-axis. In that case, you need to resolve the tension. The applied horizontal force and weight are one of them horizontal, the other is vertical, so you don't need to resolve them. Okay, so this direction of the Newton is the x direction. Now to resolve T in the segment AR, T, it makes this angle with the vertical will be 30 degrees because it is alternate angle. This 30 degree, this 30 degree. These two angles are alternate, so these two angles equal 30 degrees. Now resolve T, vertical component of T will be T cos 30 because the angle it makes with the vertical is 30. So component along the vertical is cos T cos 30 and the horizontal component is T sin 30. Now, if you resolve the second T, that's the tension in the segment BR, and the angle it makes with the vertical is equal to 40 degrees, same reason, alternate angle equal. So component of T here, the vertical component will be downward, T cos 40, and horizontal component is T sin 40. Now, we need to find the value of T and M. To find the value, since it is in equilibrium, the forces are balanced. If you consider the horizontal direction, we have 2 equal to T sin 30 plus T sin 40. Okay, from this one, T is 2 divided by sin 30 plus sin 40, which will give you T equal 1.75 correct to 3SF. Okay. And if you equate vertically, upward force equal to downward force, we have upward force T cos 30, and the downward force is 30 cos 40 plus M. So M is T cos 30 by T times cos 30 minus cos 40 divided by 10. Know the value of T, so it will be 1.75 times cos 30 minus cos 40 divided by 10. So that is 0.0175. Okay, that's the value of M correct to previous step. So this is question number 2. Now let's move on to question number 3. In question 3, you see a block of mass 10 kg, block of mass 10 kg is at rest on a rough plane inclined at an angle 30 degrees to the horizontal. A force of 120 Newton is applied to the block at an angle 20 above a line of total slope. As shown in the diagram, there is a force resisting the motion of the block, and 200 joule of work is done against this force when the block has moved a distance 5 meters off the plane from rest. And the speed of the block when it has moved a distance 5 meters of the plane from rest. So initial velocity 0. So when it moves 5 meters up the slope, let's say it can reach here. At that moment, it will have a speed. So there is a gain in KE, there is a gain in GP, and work done by this applied force, that is the external force, work done by external force, and there is work against resistance. Okay, let's calculate each thing first. Work by external force is 120 cos 20. Since we know it moves along 5 meters along the slope, so component of the applied force along the slope is 120 cos 20 times the distance. Okay, that's 600 cos 20 joule. That is work done by the external force. Now, if you want to calculate, if we calculate the GP gain, since it is gaining height, so there will be GP gain, and GP gain will be component of weight along the slope. Weight is mg, that's 100 Newton. The component of weight along the plane is 100 sin 30. That's the component of weight and the distance it moves along the slope. So it is 100 times 30 times 5 will give you the GP gain, which is 250 joules. Okay. So we have GP gain, then there will be A gain, that is half into M into V square minus U square. M is 10, V is the unknown, U is 0. So 5V square U, that's the A gain. Now work against resistance is given 200 joules. Okay, so that's it. Now, if you equate, the work energy principle, work by external force plus loss of any form equal to pain plus work against resistance. Now, work by external force here is 600 cos 20. There is no loss of energy. So 0. There are two gain. There are two types of gain, GP gain and CAIE gain. Both will be included here, 250 plus 55 V square. Then there is work against resistance. So 5 V square is equal to 600 cos 20 minus 450. So we have V equal to, calculate V from here, and V equal to 4.77, correct to CSS. Okay, that's the speed at the uh, top of the, after moving 5 meters up the plane. Okay, that's question number 3. Then let's move on to question number 4. In question 4, you see a particle of mass 0.2 kg lies at rest on a rough horizontal plane. A horizontal force of 1.2 Newton is applied to P. Given that P is in equilibrium, find the coefficient of friction. So you see on a horizontal plane, a block of mass 2 kg, mass 0.2 kg lying, and there is a horizontal force acting on it. with horizontal force has a magnitude of 1.2 Newton, and there is normal reaction, weight is downward, weight is m into z, 0.2 into 10, that's 2 Newton, and there is friction. Okay? If you get upward force equal to downward, we have R equal to 2 Newton. And if we get the horizontal forces, we have 1.2 equal to friction. Now it is a limiting equilibrium, so friction is maximum. And at limiting equilibrium or in motion, maximum friction is mu R. So mu will be friction by normal reaction. Friction is 1.2, normal reaction is 2, that is 0.6. Mu is 0.6, that's part A. Now let's move on to the part B. Part B, what is given? Given instead that the coefficient of friction between P and the plane is 0.3 and the distance traveled by P in the third second of its motion. So you need to be attentive to this word, third second, not the distance traveled in 3 seconds. Rather, from 2 to 3 seconds. In between 2 and 3 seconds, how much distance is traveled? Okay. So for this one, first we need to find the acceleration. Since coefficient of friction has been reduced, so this time horizontal force is unchanged. So the value of friction will be reduced as coefficient of friction has reduced. Same figure, but this time since mu has changed, mu is reduced, it will accelerate. So you need to find the calculate, you need to calculate reaction first. Reaction is 2 Newton, then find the maximum friction, which is mu r. Mu this time is 0.3, r is 2, so this is 0.6 Newton. Now, if you consider the horizontal direction, there is resultant force, so Newton's second law applies. And if you apply the Newton's second law, it is force minus friction equal to m 0.2 a. Okay, so a is meter per second square. Now you have to calculate the distance traveled in third second. Third second. To find the distance traveled in third second, you need to find the distance traveled in the first 3 seconds minus distance traveled in the first 2 seconds. So that will give you the distance traveled in third second. You remember the particle starts from rest. So initial velocity, if we apply ut, remember s equal to ut plus half x square. U is 0, 0 into 3 plus half into acceleration 3 times 3 minus s 0 to 2, that will be 0 into 2 plus half into 3 into 2 square. That is equal to 7.5 meter. That's the distance it travels in the third second of its motion. Okay, that's part B. I think there is no more part in this question. Yes. So that's the end of question 4. Now let's start with question 5. In question 5, we see a particle. Okay, hold on for a few moments. কে দিয়ে দিচ্ছে এত জোরে দিচ্ছে কেন? ঘোরা যাবে না 15 মিনিট মতো কাজ করে Okay, in question 5, you see a particle A of mass 0.5 kg projected vertically upwards from horizontal ground with speed 25 meter per second. And the speed of A when it reaches a height of 20 meter above the ground. So let's present it on a rough diagram. The horizontal ground, we are projecting it from this horizontal ground vertically upward with the speed 25 meter per second. Okay, so what happens to its motion? It moves to its greatest height, then returns back to ground. Now, we need to find the speed of the particle when it is at a height of 20 meter above the. So this is 20 meter. So what will be the speed here? This is if it is while it is moving. If the is we get the speed while it is moving up or while moving down. In both cases, the speed will be same because the acceleration is constant. Okay. So we know the initial velocity, we know the displacement, and we know the acceleration. So we can apply v square equal to u square plus 2as. The unknown u is 25, a minus 10. Why it is minus? Because we are considering the upward positive because initial direction of motion is upward. We are considering the initial direction of motion to be positive, upward positive. So acceleration downward negative. And the displacement that plus 20. So it will be v equal to the root of this, which is 15 meter per second. Okay, that's part A. Now let's move on to part B. See, when A reaches a height of 20 meters, it collides with a particle B of mass 0.3 kg, which is moving downward in the same vertical line as A with speed 32.5 meter per second. The collision between the two particles B is brought to instantaneous rest. So B is brought to rest. So A, obviously A was moving from the ground, A was moving vertically. So you have to show that the velocity of A immediately after the collision is 4.5 meter per second downward. Okay, so let's see what is happening here. Just before collision, let's say this way, and this is B. A is moving upward with speed 15 meter per second. B is moving downward with speed 32.5 meter per second. This is before collision, and after collision, we know that B comes to instantaneous rest. And obviously, if B comes to instantaneous rest, A must move away from B, so it must move down with the speed V. If V is positive, then our assumption is correct. Now, if we apply the law of conservation of momentum, conservative law of momentum, we have sum of momentum. If you consider the upward direction to be positive, let's say upward positive. So mass of A is 0.5, mass of B is 0.3. This is 0.5 kg, this is 0.3 kg. So 0.5 into 15 plus 0.3 into minus 32.5 equal to 0.5 into V plus 0.3 into 0. So V is, here we have V is, since the direction of V is downward, we should consider a negative sign here. 0.5 into minus V, because we are considering upward to be positive. Here V is negative, downward, so it should be minus V. So V will be here 4.5 meter per second. Then there is part C, I guess, yes. Find the time interval between A and B reaching the ground. Say at 20-meter height, just after the collide, A is moving downward with speed 4.5 meter per second, and B is moving, also moving, but its initial velocity is 0. Okay, UV. For further motion, UV is 0 and UA is 25. And both of them will move 20 meter vertically downward. And this is obviously free fall for both cases. And the time will be different because A has initial velocity, B is the starting velocity. Okay, so for A, if we apply S equal to UT plus half AT square, F is 20, U is 4.5, and T, and acceleration. What about acceleration? Will you consider positive or negative? Since here particle is moving downward, initial velocity downward, displacement downward, everything downward. So acceleration should be downward. Acceleration is also downward. So all of them, U positive, S positive. So is the acceleration. So we have the quadratic equation for t square plus 4.5 t minus 20 equal to 0. From this one, to find the value of t, so we calculate. Then use the calculator and write the answer on the calculator. So there are two possible values of t. Let's call it TA 1.6. That's a positive value, and there's another negative value minus 2.5 seconds. It cannot be, time cannot be negative. So TA is 1.6 seconds. And for B, we apply S equal to UT plus half AT square. U is 0 for B. S then 20, 0 into T plus half into 10 into T square. So T is 2. So the difference is, this is time taken by D. The difference is 2 minus 1.6. That's 0.4 seconds. That's for 6. Okay, now let's move on. In question 6. In question 6, we have a railway engine of mass 120,000 kg is throwing a coat of mass 60,000 kg up a straight track inclined at an angle alpha to the horizontal where sin alpha is 0.02. There is a light rod coupling parallel to the track connecting the engine and the coat. The driving force produced by the engine is 125,000 newtons. 125,000 newton, that's the driving force, and there are constant resistance to the motion of 22,000 newton on the engine and 13,000 on the floor. Find the acceleration of the engine and find the tension in the coupling. So let's present it on a rough diagram first. Then we consider the forces acting on the particle. This is the inclined plane. The inclination is alpha. Now this is the engine. This is the core. Now there is coupling, which is parallel to the line of grid slope. There is driving force on the engine. This is the engine. There is tension in the coupling. There is resistance on engine and component of weight of engine mg sin alpha. And for force, there is resistance on the force and there is component of weight. So if we apply Newton's second law here for both particles separately, for engine we have d minus t minus re minus mg sin alpha. D, it is moving along the slope. So d minus t minus re minus mg sin alpha, which is ma. D is 125,000. T is unknown here. R is 22,000 minus mg 100, 120,000 into 10, 1,200,000 times alpha, and sin alpha is 0.02 equal to 120,000 A. That's equation 1. This is equation 1. And for force is also moving up the slope. If you apply the Newton's second law, T minus RC minus mg sin alpha equal to ma is unknown. RC is 13,000 minus 600,000 sin alpha equal to 60,000. That's equation 2. Now we add these two equations. We have acceleration. Okay. Let's write it first. 125,000 minus 22, 13, that is 35,000 minus 1800 equal 0.02 equal to 180 A. So A is 0.3 and substitute A from 2, T is 13,000, 600,000 into 0.02 plus 60,000 into 0.3. That will give you 43,000. That's the tension and the coupling. Okay, that acceleration and the tension in the coupling. Now let's move on to the next part. The next part is at an instant when the engine is traveling at 30 meters per second, it comes to a section of track which is inclined upward at an angle beta to the horizontal. The power produced by the engine is now 4,500,000 watts, 500,000 watts. As a result, the engine maintains a constant speed. Assuming that the resistance to forces remain constant, find the value of beta. a resistance driven object. So if it moves with constant speed, there is no power. So from power, V equal to power driving force. Remember, power equal to forward driving force into V. So from this one, you can calculate the force. It is 4,500,000 divided by 30. So it will be 150,000 Newton. Remember, you can consider the same diagram, only difference is angle is now bigger, which is unknown. Okay? So if you consider the engine, for engine, we write the equation D minus T. D is 150,000. Since the equation has changed, so there will be new tension. We don't know the tension yet. And since it is moving with constant speed, so we can simplify it further. It is moving with constant speed, so acceleration is zero. The forces are balanced. So D minus T minus R E minus M G M E G time beta equal to zero for car, for engine, and for car we have T minus RC minus MC time beta equal to zero. So it will be, if you add this to D minus RE minus RC minus MC plus ME into D sin beta is zero. So D is, we have 150,000 RE RC combined, 35,000 minus MC ME, that is 180,000 into 10 into sin beta. So sin beta is 150,000 minus 35,000, and this is 1,800,000. Then beta is sin inverse this. Okay, if you write the answer correct to one decimal place, it's 3.7 degree. Okay, at part B. Is there any further part in this question? No. So that's it for this segment. Now let's move on to next one, question number 7. In question 7, we have a particle X travels in a straight line. The velocity of X at time t-second after leaving a fixed point O is denoted by v meter per second, where v equal to this. A particle in question 7 is say a particle X travels in a straight line. The velocity of X at time t-second after leaving a fixed point O is denoted by v. G has a cubic equation. Acceleration of X at t equal to p and t equal to q is 0, where q is the larger value and p is the smaller one. You have to find the value of p and q. So for this one, you have to find the expression for acceleration. And since v is the expression of p, so acceleration is the differentiation of v with respect to t. So it will be minus 0.3 t squared, 1.8 into 2, that's 3.6 into t minus 6 plus 0. So that's acceleration. Now set this acceleration equal to 0. So we have the quadratic equation. If we divide it by minus 3, we'll get the equation t squared minus 0.3. If we divide it by minus 0.3, we have t squared minus 12t plus nt equal to 0. So it's a quadratic equation. You can break it or you can use the direct formula. Since there is 4 bars, why don't you show the middle come break here? So if the linear factors are t minus 2, t minus 10, so t equals to 2 and 10, so p is 2, q is 10. That's the value of p and q. Now, the second part, it is given that the velocity of x is 0 at t equal to 14. Find the velocities of x at t equal to p and t equal to q. Then, hence, get the velocity time graph. So, when at t equal to 2, velocity is minus 0.1 into t cube plus 1.8 t squared minus 60 6 into 2 plus 5.6. This will give you the velocity of the particle at t equal to 2 seconds, which will be 0. Then at t equal to 10, the velocity is minus 0.1 into 10 cube. Remember, the expression for velocity is this one, right? Minus 0.1 t cube plus 1.8 t square minus 6 into t plus 5.6, which is equal to 25.6 meter per second. Now, we know the velocity and the initial velocity. What is the initial velocity? And we also know that at t equal to 13, the velocity is 0, and at t equal to 0, v is 5.6. Okay, so that's the velocity, and it's a cubic expression. So velocity is also positive, and there will be also negative velocity. Of 156 at equal to 0, velocity equal to 0. Then we have at equal to 10, velocity is at equal to 14 second, velocity is okay. This is velocity time graph. Okay, so we don't get negative velocity here. So this is 5.6, 24.6 to 14. And this is 10. Then in the next part, okay, you have to continue the velocity time graph up to t equal to 15. Let's draw it. This is equal to 10, 14, this is 15. At t equal to 15, what is the velocity? We have to calculate this. At t equal to 15, velocity is minus 0.1 into 15 cubed plus 1.8 into 15 squared minus 6 into 15 plus 5.6, which will give you. So this is minus 16.9 meter per second. So that's minus 16.9. Since it is case, so scale does not matter. Okay. Now that's part B, this case of velocity time graph. Now let's move on to the next one. Find the total distance traveled by x between t equal to 0 and t equal to 15. You see, we can find the total distance traveled between t equal to 0 and 2 first, then t equal to 2 to 15, then 15, 14, 2 to 14, then 14 to 15. You can also calculate uh, the distance traveled between 0 and 14 directly, because in between velocity is not negative. Velocity becomes negative after 14. So 14 to 14, eh, during this time interval, you have to calculate the distance traveled separately. Okay. So for 0 to distance travel in 0 to 14 seconds, we have to integrate velocity in this interval. And velocity is minus 0.1 t cube plus 1.8 t square minus 60 plus 5.6. Integrate this one, you have substitute the limit 0 and 14. You substitute 0, it becomes 0. And if you substitute 14, it becomes it is 176.4, and from 14 to 15 it is this will be a negative number minus 8.035. So total distance on 76.4 plus this. Now, you might wonder, some of you might wonder why we took two separate interval and then find the distance to travel in each interval, then add these two. The reason is very simple. You see, if you look at the graph, if you look at the velocity time graph, you see, from 0 to 14 seconds, the velocity is positive, that is, it is moving forward. After 14 seconds, the velocity is negative, so it is moving backward. So it is returning. So if you consider the motion trajectory, after 14 seconds, it moves forward. Then after 14 seconds, it gets returned back at t equal to 14. It changes its direction. So from 0 to 14, it moves forward, and 14 to 15, it moves backward. But since we are calculating the total distance traveled, you have to calculate this, all the path. You have to consider all the path and you have to add this. So that's why from 0 to 14, we found the displacement, and 14 to 15, we find the displacement separately, and 14 to 15, you see the displacement is negative. It proves our assumption. Okay, it confirms our assumption. So since we are calculating the distance, so we'll take the positive value of this, numerical value of this, and add this to distance travel. So that will give you the total distance travel. Okay, that's the end of this question, and that's the end of this paper. I hope you understand all the questions, all the working. And if you have any queries, please mention it in the comment section. And don't forget to like the videos and subscribe into my channel. See you in the next video. Until then, Allah Hafiz. Assalamu alaikum. See you.